All right, welcome to Ruukki Sound Environment webinar. Today we have a compact 1 hour presentation on our new embedded acoustic solutions. My name is Jyrki Kesti and hosting this webinar today and also give you an overview of new solutions. And another presenter today is our acoustic specialist Erkki Honkakoski.
Hello.
But before we start, we will short 2 minutes video on our solution in brief. All right, now we are ready to start. And please note that there is a chat area where you can write your questions in any time, and we will try to answer them in the end of the webinar latest. And please also that this webinar will be recorded, so afterwards you will get this recording with your emails a few days after this event. We have divided our webinar to 2 parts, where the first part gives an overview of embedded sound environment solutions, product portfolio, and the benefits of the systems. I will tell you also about our first pilot project and something design tools. In the second part, Eki will go a bit deeper into background and technical performance of the solutions. Good sound environment is essential for well-being and work efficiency, as we all know. If you ignore acoustics in the development phase, you probably need to start fixing new buildings because they sound wrong. Ruukki Sound Environment includes a range of profiled load-bearing roofing sheets and cladding solutions, especially for big box like buildings like sport arenas, industrial halls, schools, and also for commercial buildings or logistic buildings. The solutions cut out the background noise, reduces echoes and reverberations, despite where the noise is originated, inside or outside the space. In our new solutions, we have products up to class A absorption class, that is basically as good as it gets. We made a customer survey in 2021 and found out that about one third of the building projects acoustic performance is improved afterwards because of insufficient performance. And this gave us a motivation for develop a cost efficient building embedded acoustic solutions. Our sound environment feature, it is embedded in a building envelope, just similar to the fire safety or thermal comfort, for example. Of course, we know that there are different requirements for different buildings, but our basic components, they are always same without need for major tailoring. Our solutions are optimal for end users in different spaces. It's clear that the good sound environment enables safer work, lower stress level, and also improve productivity. And it's really the building envelope that finally defines a room acoustics. It covers both sound insulation and noise reduction, and our solutions meet different needs. We have used to separate sound insulation and sound absorption and design those separately. Even both of them have a common effect. But we know that the good sound absorption has also a positive effect on sound insulation. And this is especially handled more on part 2 of this presentation. Eki will give you good examples how to utilize this phenomenon. Before we jump to our solutions, it's good to see first some very basics for sound absorption properties. Sound absorption classification is used to compare different absorption products and materials. In those classes, class E is hardly sound absorbing, while class A and B are extremely absorbing materials. Absorption coefficient is depending on frequency, and the bigger it is, the better is absorption performance. And it's good to notice that this classification is for material and product, not for spaces or buildings. Now, why it's good to have a sound absorption in the space? Sound absorption reduces sound energy, reverberation time, and echoes in a room, creating a more pleasant sound environment. Then I show you some of our products related to sound absorption. We start with the roof application, and this this page we can see those web perforated sheets that we already have had decades in our portfolio. In this profiles, this web area of the load-bearing sheet is perforated, and we can, if we use this very, let's say, basic structure where we have a sheeting, top of that thin mineral wool layer, and then water vapor barrier and other insulations and roof covers. Here we can reach the sound absorption class D, meaning that about 35% of the noise is absorbed. If we increase the infills, acoustic infills into the grooves of the profile, we can improve to the class. We will stay in the same class, but we can improve this weighted absorption coefficient to 0.45, meaning that 45% of the noise is absorbed. And we can still improve that, adding a perforated cladding profile on the underneath of the system, and with some light non-woven layer here. Here we can increase the class to C and have this coefficient to 0.70. But what we have really new, we introduced last autumn the totally new profile. This profile is T153 in our portfolio, and here we increased the whole area in this profile so that we have not only in the web area but also in the upper flange and also here in this upper web area, more this perforated area, and also this perforated area. This whole diameter was bigger, so this perforation rate within this perforation, this open area is higher. And here we can reach even with this very basic structure, the absorption class B, that is actually already very good property with this coefficient 0.80. Adding in this system those acoustic infills, we can reach absorption class A with 90% absorption. And here, if we here add again underneath the perforated cladding profile and those underneath those acoustic infills, we can reach the 100% absorption. And this solution, as our Eki said it, this solution is acoustic heaven. We have also completed complementary products for walls and ceilings. We have two products, ready-made solutions, and this solution is suitable for any background wall structure, is it a sandwich panel or any other wall structure. The solution includes these rails and then these perforated design or low profile products, and then it needs the system needs a mineral wool layer behind the cladding. In this 100 millimeter case, we can achieve this absorption class A with 90% absorption, and with 50 millimeter absorption class C with 50% absorption. This MH means that this performance in a medium and high frequencies is better than the class C. It's actually as good as in this class A in medium and high frequencies, but in low frequencies the performance is lower, and for that reason this class is as C. It's also good to notice that this cladding system also improves directly the wall RW value, this laboratory measured value. 100 millimeter case about 10 decibels and 50 millimeter case about 6 decibels. And if you use this system on walls, they really removes the flutter echoes between the parallel wall surfaces and improves absorption properties, of course, both in wall and ceiling surfaces. Maybe the following example motivates to consider the acoustic planning in an early design phase and to utilize embedded solutions. In this example, we have two solutions with a similar, quite good acoustic performance. In a left side case, we have a regular roof structure without the perforation in seating, and the absorption is realized through the separate acoustic ports installed underneath. And the cost of acoustic solution, this case is about 40 to 50 euro per square meter, including material and installation. On the right hand side, there's a new Ruukki solution with our new T153 Acu B profile, with the same upper layers as in a standard solution. The additional cost compared to very normal cost non-perforated roof, the additional cost of this acoustic solution is only about 30 to 40% of the add-on solution shown here. Our first building is a paddle hall in Seinäjoki, where our main solution was the acoustic load-bearing roof structure I showed in the previous page on based on this web and flange perforated seating. And we have received a very positive feedback from the building owner as well as from building users. And the operator is happy because now he can even have work meetings in the lobby area without disturbance from the playing area. We have a set of design tools also at your service. This is the new tool in the left-hand side, is a Ruukki Acoustic Estimator. With this tool, it's very easy to estimate the reverberation time in a room when you give dimensions for the room and the main materials used in the roofs and walls. And then, of course, we have those traditional tools, Poimu design tools, for the design for those load-bearing seats, structural design, and all necessary BIM objects also to use in a design. Now, what are the benefits then from the solutions? In Ruukki load-bearing acoustic roofs, the sound absorptive surfaces, they are integrated or embedded into load-bearing roof structure. The layout is more cost efficient than installing absorptive materials from below separately. The sound absorption can be adjusted easily depending the need, up to Class A absorption classes. In claddings and ceilings, the perforated design profiles create elegant architecture image. And the cladding solution completes the roof solution and removes flutter echo between walls. And it's also good to remember that good sound absorption in envelope increases also sound level difference between spaces. Okay, and then I will give a floor to Eki to continue this part 2. And please remember to use this chat area and answer put your questions there. Thank you.
Thank you, Jyrki. And hello, everybody. So we go first some physics, basic concepts about sound, room attenuation, sound insulation, sound absorption, and sound reverberation time, and how these links together. And we go through also how the Ruukki Sound absorptive cladding solution works and how Ruukki load-bearing acoustic works. Then estimation tool and pilot case in the site measurements. I have a more text here than it's meant to that when you receive this material, you can, it is explaining more detailed. We are not going to go through all the text in here. Okay, is it like this? Okay. So what is sound? Sound is a mechanical disturbance moving eye molecules and therefore there is a work done on the eye molecules and they start to vibrate. And this disturbance spreads far away by molecule collisions. Sound can reflect, absorb, diffuse, or bend on the way while traveling, and they can do work by vibrating large surfaces. So air molecules are going, not traveling with the sound, but they are vibrating back and forth and creating a particle group pressure. If we think that this line here is atmospheric pressure, and the black line here is amplitude of vibrating pressure level back and forth. The particles has also the second property, and it's particle velocity. It means that in dark areas where there's a lots of particles, they are not moving very much. They are compressed, and with the rare area, when the pressure is lower, they can move more vigorously. So there is a phase change in here. When the pressure is in zero in the atmospheric level, you can see here that the velocity of the particle is at maximum or is at minimum. So there's a phase change in these velocity and pressure curves. So sound intensity is a sound energy flow on the area. It's watts per square meters. And the energy, how many watts there is in a sound, it's a very low value. So 1 watt per square meter is a low energy density, but it is the sound volume is a decibel level 120. It's a threshold of pain, and the threshold of hearing is a quite low energy value. So from the sound mechanical disturbance, usually it radiates more or less to all directions, depending of the what is causing the sound. And it means that when the sound is spreading all around, it dilutes for large areas in open space. And this means that the sound intensity is then getting smaller and smaller because it's per watts per square meter. So the same energy gets the more area as more far we go. So it means that 6 decibel every doubling of the distance is sound is attenuated. And if the sound source in case of room is closed in a box, it means that sound is accumulating inside the room or inside the box. If there is no sound absorption happen, if every surface is reflective, the sound bounces back and increases the sound level. So in very reflective room, surface room, there is an increase of +6 decibels. How to control or reduce the sound intensity? We have this intensity, and there was this pressure, and there was this velocity. And if we are minimizing both of those or one of those, then the sound intensity will go down. So pressure property and its implications are often minimized in the sound insulation tasks. And the velocity property how to slow down the air particles movement is a target when sound is absorbed. And when it's absorbed, it's destroyed to heat. So with the pressure property, most efficient way is minimizing creating the noise in first place. You can select more quiet processes or machines, think the location where the noise sources are or noise is created. You can insulate and attenuate it as close as a noise source as possible. So you don't need to use large surface areas to decrease the noise. And if you make sure you don't conduct the sound and the vibration, mechanical vibration through connection or other structures, it's a good way. Then the velocity property, it's when you use sound absorption in structure cavities to reduce accumulation of mechanical resonances or empty cavity resonances. Or you can use sound absorption in a room to reduce sound reverberation time and accumulation of sound intensity in the room. So, blocking the sounds between different spaces. Many times the target is to have a large enough sound level difference between spaces on site. Is it outside or inside or between two rooms? There is this wall as a partition and you want to decrease the sound in this room. And sound level of difference depends on sound level of sound sources acting on a partition. So how loud is the noise that we want to block out? And partition area, room size and volume affects also what is the intensity inside the room. Partition materials as assembled, the partition eye tightness, other roads, vibration, flanking sound, and the partition material sound insulation value. But also the sound absorption and reverberation of the receiving room affects the sound level in here. Sound insulation alone does not define how sound behaves inside the room. So the sound insulation, what is this wall and what is the sound insulation property of this wall, doesn't guarantee a suitable sound environment inside this room when the room itself has its own sounds inside. Okay. So how reverberant and echoing the room affects the sound environment and also sound insulation and sound level difference. Here is the room attenuation curve, and it depends how much perfect sound absorption is used in the room. So it's this class A perfect sound absorption area. And in here you can see this type of envelope effects of the room, that there's a negative decibel numbers in here when you don't use enough sound absorption. So this means that the room is acting as an amplifier. And in order to get in the level that to the open area, you need to use some sound absorption in the room. Otherwise, you are amplify the sound inside the room. So this is plus 6 decibels. It's but we cannot make a perfectly reflective wall either. So it's like plus 5 decibels in practice, the sound amplification, if there is no sound absorption. When you add their sound absorption, for example, roof is a good place, then you are attenuating the room sound level. Here is one example that the on-site sound insulation needs a level, imagine that 20 decibel for facade partition, for example. If the rooms behind have a different reverberation times in here, the demand for facade RV value, sound insulation value, becomes different to each to reach the same sound level difference. So in here, when you double the reverberation time, you increase the RV need by 3 decibels. So what is the possible solution in here? That what is this facade? Do you use RV 37 decibel wall? That is as a demand. It's too much for here, but clearly this RV 28 wall doesn't performance not enough for this room that has a long reverberation time. Or you can call for sound absorption roof and walls solution to help here to reduce the reverberation time. So when you use this sound absorption and reduce the reverberation time in the room, the users and owners don't only benefit sound coming from outside to inside, but they have an adequate sound insulation and improved sound environment inside. And it's a good idea to invest this type of active spaces, the acoustic conditions. And the active spaces are usually the productive activities, and payback is created there. So sound absorption part. So if you slow down particle movement, you decrease sound intensity. And in that case, you don't reflect the sound elsewhere to others' problems. Perhaps you destroy the noise by turning it to heat with sound absorption. So this Jyrki already told that this weighted sound absorption coefficient alpha W is one number value for material capability of absorption sound relative to human hearing. It's a ratio of absorbed sound to indirect incident sound. Larger the value usually is better. Value 0 is all sounds bounces back from the surfaces, and value 1 is no sound bounces back. So the roof absorption area we talk about, it's called Sabin square meter. It is in a room, it is a sum of room surface area with the perfect sound absorption 1. If you have a lower value, this alpha value, let's say 0.5, then you can use double amount of material to reach to 1 square meter Sabin value. If you need to use 80% of area with with the good sound absorption material, you can reach the same operation when using 0.8 material over the 100% of the area. So this total sound absorption is calculated in that sense that you can vary the material and the used area there. Doubling the sound absorption area improves the sound attenuation by 3 decibels. And also when placed on the wall, for example, it improves the sound level difference between the rooms or outdoor. So, how Ruukki Sound Absorptive Cladding Solution work? It has this double effect. So, high and extreme sound absorption reduce sound reflection and accumulation of the sound and sound intensity inside the room. And when it's used on the wall, the iPod sound insulation of the wall partition improves in the word's first meaning. How much it depends on the travel distance through the sound absorption material. That's why the for example 50 millimeter doesn't work as well as 100 millimeter, or even if you are making thicker or make an air cavity between there. So, but this is a sound insulation value measured with some other material, and similar improvements for the sound insulation value is find out in also in other structure. So what Ruukki has done, it's optimized the operation with the lightweight mineral wool, contributing the room attenuation and reducing echoes and reverberation. In this measurement test, there was a more density was twice with the mineral wool, but the effect is the same with lightweight mineral wool too. How much or how long reverberation time is needed to be? It's short enough. Shorter the sound reverberation time, better it usually is. And it's a little bit varies for the internet room usage. And there is some recommendation or national building codes have a recommendation of sound reverberation time of different uses or different buildings. And Finnish National Standard 5907 acoustic design and acoustic classification of building has the latest collection for Finland. Usually there is a lack of guidance for some larger rooms and halls with mixed usage. But when there's a spoken communication is important, sound reverberation is short enough for proper speech intelligibility. Every reflection for the sound disturbs the original speech and the intelligibility of how well it's heard. So around 1 second in the rooms where there's an accurate conversation needs group working, monitoring, presently learning, concentrating or teaching involved. Or it can be even less. Around 2 seconds or less could be acceptable for larger rooms with customer face-to-face services, group coaching type situation, like in shopping centers and sports halls, for example. Okay. We are talking about the load-bearing acoustic works, and this is for the case for the paddle hall. We are going to look more detail in the next slide. We have acoustic estimator at work, and it is working so that you can add their materials and calculate very easily. You first put your dimensions there, for example, length 40 meters, wide 25, and height 8 meters. Temperature doesn't affect so much, but relative humidity has an effect there, and you can see from the graph that there's some things. So with calculating with this, with having a sound reflective floor and walls and roof with in this case with concrete, and you can reverberation time around 8 seconds there in the room. So this is like a parking hall that maybe this is not good for teaching or explaining something. Likely you don't want to spend there much more time, and all the noises are increasing about 6 decibels in level. If you change only the roof there, you can drop that around 2 seconds. And here what is changed here is just this basic structure roof that the Ruukki has now at the offer. So quite good drop in there. So I like to give a note about this calculator and this Sabin equation. It has a limitation if sound absorption material is unevenly distributed to the room. For the calculation, it doesn't define where they are. It is calculating so that it is evenly distributed on the room. Of course, in the floor we cannot put sound absorption at least much. But if it's very uneven, like in here, sound absorption in the ceiling only, the diffuse sound field requirement for the calculation is not actually met, and the estimation can have some minor overestimating the thing, and the same happened in this paddle hall pilot case estimation. So the size was a little bit larger and quite a big paddle hall, and calculated as a reflective made from reflective surface material. It was here around 12 seconds the reverberation time. And we changed the roof for the basic load-bearing structure, and the estimation of these I went to 3 seconds. So here we are comparing the estimation calculated from the tool and the real measurement. Here is as a weather tight, and then we added there's some furnitures, and we added some wall absorption in here for the large of the hall. It's quite just 70 square meters. But we can see that over 1000 hertz we get to the level where we were needed. And the reason for this deviation in here is that sound absorption is mainly in Z-axis, and it's not not distributed evenly in this hall. So most of the walls are bare sandwich walls and reflective in nature. But even the latest acoustic recommendation in Finland that came a little bit later on, it is not met here, but the customer is quite happy because we can preserve these very important frequencies here for the speech and communication. And yes, okay. You can ask more questions about this if you want to have. We check a little bit what is the load-bearing seats in a comparative height of the load-bearing acoustic roof solution and performance. I studied in this. This picture contains lots of information about acoustics of the room. Here is wellbeing. It is against room acoustic principles, good ones. It's a very reflective ones, and then here's a well-being when according to good acoustical principles when there is sound absorption used. So there's a classification of the absorption thing, and then this arrow is this neutral position when the building envelope sound amplification is compensated in here. Here are some products. Usually we are in this absorption, this ill-being side, close to neutral point. And now our new products are here in the extreme absorption side, this well-being side. You can study this more, and also the noise levels. You can study more on this when you receive this material. So how roof structure can benefit sound insulation of facade? So the sound absorptive roof structure reduces sound reverberation time cost efficiently, and absorption of the wall solution improves sound insulation value of the wall itself. In this curve you can see that this dotted line when we are using the 50 millimeter, we improve the next dotted slide, and if we use 100 millimeter, we improve the sound facade sound insulation to the next dotted line. Then the red dotted line in here, the room has a reflective roof or ceiling. And if we go to the Ruukki load-bearing seat with acoustic infill and get the good class A level, we have a difference with the sound level difference and the sound insulation. There is an improvement, so the sound level drops in the room, and this insulation task is more easy. So this is about the 10 decibels, up to 10 decibels, and this is already a good level. So the wall component RV value can be reduced even. And so you can find more information on these links and study more detail about this. That is found in design instruction page 24 and all the tables that can be found there. So using our acoustic load-bearing seats and cladding, you will have a full control of acoustic conditions, achieving a productive environment for many intended tasks. It is not possible to get rid of all noise sources from the environment, but you can effectively reduce the effects like noise levels, spread of noise, reducing accumulation of background noise, and therefore suppress many harms and inefficiencies the noise can create. And please welcome to our website. Everything is collected on the one address, and there's information available. Yes, do we have some questions there? Of course, it's depending of the mineral wool type, but the U value, of course, increased the.
I think probably the question was worry about the condensation problem, so that so that in order to avoid the condensation in a wall, if you increase the lot of insulation inside the sandwich panel, it may be that the inner surface is too cold and it might the condensation. But typically this rule of thumb having a maximum 1/3 of the thermal insulation inside the vapor barrier, that should be okay. So in this case, probably about 200 millimeter sandwich panels should be still quite okay to use.
Oh yes, thank you.
And in those technical data in our website, you can find those frequency-based values for those different solutions, those absorption coefficient values for different frequencies. And maybe if there are not any, please add your questions if you have more. Meanwhile, maybe Eki, you can have a short introduce to our web pages, how to find there. And
yes, where was the share option in here?
it is in the left hand side.
Yes.
And share only the
Okay, the page, if you can see it, it is looking like this. And here's the building envelopes and products. You can find sound environment solution in different places in here. For example, here you land in the same page, and then you have this basic story there. You have a video that you just saw, and you have a case of this paddle hall information. Then you can have a portfolio, and when you are clicking this, you can see the information about the structure, how it's made, what is the sound absorption and sound insulation values in here. Also the graph, there will be updates on there also. And you can have a link to design tool. And for example, same in roof solution, and you can have a structure and the performance, and then the detailed value of the measurement and the graphs about that. Then you have this design tool we can look then, and then there's a technical documents about this. So there's a design instruction about this, what we talk about. Then there's a sound insulation value for various structures and sandwich panels, including this sound absorptive things. This we are every time we have something new, we update this file when there's a laboratory measurements made or something like this. We can go to the can you see the Ruukki acoustic estimator tool at the moment?
No.
Okay, I changed the.
But maybe we are probably a little bit lacking of time. We have 4 minutes time. I don't know if we have a time to go. Okay, you can try to open. But meanwhile, still, if you have any questions, so please add, and also remember that you will receive this presentation material as well as a link to this recording of the webinar by email. And you are, of course, you are free to distribute this material to your colleagues to see the same presentation and also get introduced to the material. Okay, Eki just open this. We have a few
this
minutes
works
time.
so that you give you get you give a name there. You give let's say some dimensions of the hall like that, and then you give a temperature. This is more like if you are using making a ice rink or something, the temperature could be very low and it affects the relative humidity, and that's why it's there. Then you just click the material settings, and if you now apply, so it calculates, it means that all the surfaces are concrete and reflective, sound reflective material, and you can see what you are going to get in the sound reverberation time. Then you are here adding something. Let's put this roof with full surface, and we take out the concrete there, and then we apply and calculate that thing, and we can see the effect. And of course, this is now unevenly distributed. You should be noted that this is a little bit overestimating in here. And then you can have a report out of that. Okay, sorry, you cannot see that, but it tells you what materials are used, what are the surface areas, and etc.
Okay, thank you, Eki. Just get the suitable time to introduce the tool also. But it's time to thank you for your attending this webinar, and hopefully we will see you in our future webinars too. At least we have something on sustainability still coming to before the summer, and so please follow our news. Thank you very much.
Thank you. Bye bye.
Bye.